Welcome to Code Club. Thanks for joining us. I'm here with Jakub and Andrew and Thom. And as usual, we're going to parachute into an unknown and potentially hostile code base, undertake a reconnaissance mission, and we're going to see what intelligence we can gather about what this project does and how it works. So let's take a look. So we're looking at a project called Nabu today, and it is a port scanner. Is that term familiar to anybody? Do we understand what port scanning is or why you might want to do it? Any ideas?
Presumably we have a server running somewhere that's got ports available on it, and we want to see which ones are available. Is that accurate?
Yeah, that's right. There's a tool called Nmap which does this, and network administrators will be familiar with this because, essentially in TCP, you have your IP address of your machine or server, and you also have some ports open on it or not. So if you have a server running, it will be listening on some port, like port 80 for web servers. But there are lots of other ports, some of them well known, and assigned to certain services, others not. And it can be very interesting if you don't know much about a machine to scan it to say, what ports do you have open? You could figure out what sort of thing it is. Like if it's listening on ports 80 and 443, that's probably a web server of some kind, isn't it? If it's listening on port 22, it's probably a Unix machine that has an SSH server, something like that. So why would you want to do this scanning? Well, as a network admin or security person or server admin or whatever, you would like to know what ports am I exposing to the internet, let's say. Are they the ones that I wanted to expose? Or, presumably we're exposing some ports, so we won't be able to do much. But it's easy to accidentally leave ports open or to have a service listening publicly that should only be listening on localhost, let's say. So it's very useful to use a port scanner to check what's open, and of course if you're someone more nefarious and you're looking for some way to attack a machine, this would be a great place to start, because the port scanner will tell you, hey, there's something listening on this port. We won't necessarily know what. There are ways to try and find out. But at least we can say, hey, these ports are open. So how would we do this? If we were going to write this program, we don't have to, fortunately, but if we were, anyone like to speculate wildly about even what basic approach we might take?
I mean, this is absolutely not my area of expertise.
No, nor me.
I would start by looking at what's in the standard library for, like the net package.
Yeah.
And kind of start from there. How do I pass an IP address and get back a bunch of hosts?
Yeah, that's right. I think, given some host or some IP address, I think what I would do is try to connect to that host on port 0, let's say. Or I don't think that's a valid port, but port 1, does that succeed? Like there's a net.dial standard library function which just makes a TCP connection, like a byte level connection. It's a network socket. That either succeeds or fails, If there's something listening, it ought to succeed, and if not, it will tell us. That's why. So I try port 1, port 2, port 3, and then keep going, and I think the ports go up to 65,535, like most
check
things.
one by one if
Yeah.
it's listening or not. Can we connect?
Basically, it sounds dumb, but that's the scanning part of it, isn't it? It's just trying every port, and of course that's quite an expensive operation for both of us, right? I'm using a lot of resources, making lots of network calls, and I'm also occupying a lot of resources on that target machine. So probably goes without saying, but I'll say it anyway, you shouldn't scan machines that you don't control without permission. Partly because it's annoying, and partly because you might find the police turning up at your door. I mean, you never know. This library exists to do it. So let's take a look and see if we can dive into it. Now, I've looked briefly into this myself, but I haven't kind of preloaded a bunch of knowledge about what's going on. I think that's more fun, actually, if I'm as much in the dark as you all are. So I don't know.
Reminds me exploratory testing.
Right. So I won't know the answer, so we'll try and figure it out together. So the first thing I notice is, like, I'm not going to go through the README, or we'll just take a quick look. But basically, this is a CLI tool which you can run, and you can give it a host address to scan, and it will basically tell you all the ports that it finds open. That's straightforward. So we'll see how we do, and we think we have an idea, and we'll see if that's what they're doing. The first thing I notice here is that in order to find the package, it's under a v2 folder. Anyone any ideas why that might be?
Maybe this is a new version of this. Maybe there was a v1 at some point, and now they don't want to have that folder in there.
Yeah, that must be it, mustn't it? And but you might well say, well, what if it's v2, then why isn't it just v2? Why is there a folder for it? And the answer,
I would normally think the command and the package would be up, kind of at the root level of the repo, maybe.
Yeah,
That's
exactly.
Unusual.
And I think the answer is because of Go modules. So, some of us may know. One thing that Go modules does is when you import some library like this, you have an import path that you specify. Should be the first thing listed in your README, shouldn't it? Except this is a tool, so fine. But there is some library involved. And, you can tag your repo with git tags indicating the version, like v1.0.0, something like that. But what Go modules does is when your tag reaches v2 something, it forces you to make a different import path. So it's kind of saying, v2 by definition of the semantics of semantic versioning is this contains breaking changes for code that used v1, right? You had previously written programs against v1 of this library, and they worked, and I am now breaking the API because I need to. Those programs will no longer work if I just pushed this code. So what I'm doing is I'm tagging it v2 to indicate new major version, breaking changes, and it is effectively, as far as Go is concerned, a whole new project, whole different library. So that's why this v2 folder exists. Is to now when you import Nabu, you will import github.com yada yada nabu/v2. So that's it's quite nice because it means all of those programs against v1 won't break, or not for this reason. So that's fine. So as the author of some library or program that uses this library, it's down to you to say, am I interested in updating to v2? If so, I can do that by importing the new path. If not, fine. I'll just carry on. If I'm happy with v1, I'll stick with v1. There's no way for the library author to force you to upgrade. And if you've ever been forced to upgrade a version of some dependency when you didn't want to, you'll appreciate this.
And you broke your code or program in production.
Exactly. So when my code breaks, I want it to be because it's my fault. So that's just a prefatory note. So let's take a look. So yeah, we have a CMD and a PKG. I think we know what these are about, don't we? We expect to find a CLI tool in here. Here it is. This is a nice short main.go. I like a short main.go. It means you don't have to do a ton of paperwork to use this tool, or to use this library, which is nice. I can't stand paperwork. So this is usually a good entry point, isn't it? Even into a library, it's just to say, well, if there's a tool attached to it, what does the tool do? How does it use the library? So let's take a look. Thom, perhaps as the senior student present, you do us the honour of just starting reading us through this and looking at what the code says.
For sure. So we're first going to set a variable options to whatever gets returned from parse options. It looks like that's reading both command line flags passed in as well as configuration files.
Yeah.
Based on the comment. But I'm going to end up with some options. And then I'm going to create something called a runner with those options. And fail. Interestingly enough, it looks like they've created and or wrapped their own logger.
Right.
Here, so not sure what that means yet or what the purpose without reading the code.
Yeah, this project discovery organization, I think, is, I looked at this before, it's, they do something related to security and networking tools. Yeah, project discovery. So they seem to have a bunch of related tools around this stuff. So GoLogger appears to be one of them.
Could be one with their library. Yeah.
Yeah, don't know what this logger does, which the standard logger doesn't do, but we can at least fairly confidently peg it as something to do with logging, can't we? So what do we think these options might be? Let's find out what. Oh, it's a pointer to a runner.options. That sounds weird.
Makes sense.
I would have thought it would be a slice of something.
I mean, maybe there's only a distinct set of things and they're different types.
Yeah.
You know,
Could be pointed to struct with a bunch of configuration stuff in it.
Yeah. Yeah, I think I'm confused by the name options because I tend to jump to thinking about functional options these days. And we've talked about that previously on Code Club. And this is very nice because as we discussed, if you have to pass options to something, if they're all parameters, then you always have to supply all of them, which is annoying. Paperwork, right? And if there are sensible defaults for any of them, we would like to be able to omit them. Go doesn't let us do that syntactically, but we can have it take variadic parameters. And one of the nicest things to supply to it is functional options, which are functions, as the name suggests. So options here would be some slice of functions, each of which sets some option on a runner, whatever options there are. That's not what they've done here. I think what we're looking at here is basically a config struct, isn't it?
yeah.
As Andrew said, it's some struct where its fields represent the options and it will parse its flags and config and so forth. And we don't care about any of that. We're interested in getting to the bit that does the stuff. And I suspect a runner is something like, I tend to do this sort of thing too, and I'm sure you do, is I don't want to put all my code in main because I'm interested in writing libraries. So at least the core business logic is going to be decoupled from main. We're going to put that in some package, you know, my struct type and methods, things like that. But there's also some stuff to do with being a CLI tool, like command line options and arguments, input, output, logging, that kind of stuff. I don't want to have to write all of that in main, because then anybody who wants to use me as a CLI would have to do it. But it's also not part of the core package, so it's a package that's about being a CLI tool that uses this library, just not package main. So I suspect that's what it is. And then, sorry Thom, I think I interrupted you. We got about as far as new runner, didn't we?
No worries. We can presume that if an error returns from calling new runner, that our program will exit and log out, could not create a runner. And then it looks like the next step is to take that runner and to call something called run enumeration on it. Again, the naming is interesting here, kind of similarly to parse options, where, you know, I know what an enumeration is, but it doesn't necessarily seem pertinent to this context on the surface, right? But I don't know what they've got under the hood, so we're going to essentially run the program, it looks like, now that
nothing else happens, does it? So this must be the thing that does the stuff.
Yeah.
Let's take a look, shall we? Okay. How about Jakub? Would you like to help us here by we'll just start reading, try and figure out what does the code say, and then we can worry about what that might mean.
Yeah, so we have exported function here, the run enumeration, that just in case return error if it's happening. So we are checking, I presume, if this root is related to a system user, or we are in the root of some. I would say so, because we should be able to run this tool as a CLI, so we can run from whatever part of the system.
Yeah, I think
that was my first thought.
Yeah, I think I would guess the same thing. If is root is saying, is this program being run with root privileges, so that we can do, you know, advanced adult situations with the networking stack.
Yeah.
But we can confirm that.
And then the sync scan is one of the options.
Mm-hmm.
Then we are setting up handlers on the scanner.
Yeah, I think we don't know what synscan is yet, but I vaguely remember from CS school, which I'm sorry to say was a while ago, that you know, if it's setting up a TCP connection, I think you send a TCP packet called a syn packet, which is like a request saying, "Is anyone there?" And if there is someone there, it will send you an ACK packet saying, "Yep, someone here," and then you can have a conversation about what you want to do. So I'm guessing synscan is just like send a syn packet, see if you get a response, and clearly we need root privileges for that.
Yeah. And then we are setting up some background workers. So there could be some workers that would perform this actual scan.
Yeah, what was the setup handlers bit? We don't know what setup handlers do. Let's see if there's a comment.
No.
Setup handlers to listen on all interfaces. Fine. We'll come back to that. Yeah, background workers, don't know. Maybe it'll become clear.
So I could presume there is maybe number, depends on the options, that if we, for example, choose a couple of the IP addresses to scan, every single IP address is assigned to a separate go routine maybe, but it's just right now.
Yeah, that's the point, because we can scan multiple hosts, can't we? But even if we were just scanning one host, we wouldn't try each port sequentially. We could try 65,000 ports concurrently.
Yeah. Okay, so then we have source and IP and interface. Okay, so we are setting up configuration here.
Yeah, I suppose if we're just making outgoing network requests, they will, by default, probably come from whatever our public TCP interface is, isn't it?
Yeah.
But perhaps we maybe want to spoof our IP address so that the police don't show up at the door. And maybe, send on a different interface or something. So that looks like some kind of option, doesn't it? Or the comment suggests it's some kind of option. Set values if those were specified via CLI. Otherwise, try to obtain them automatically. Don't know what any of that stuff is about yet. But that's completely normal, When we're reading some random code base, we're not going to know what everything's about, but we've just got to try and cope. It's like, I think of it like if you go on holiday to a foreign country or visit somewhere where they don't speak your language, you've just got to try and survive, haven't you? Yeah. Starving to death and not making your way back to the airport is not an option.
And actually, this situation, it just highlights how important it is to use clear naming conventions for functions, for parameters.
Very much so. This is literally the only information that anyone will have.
Yeah.
Go ahead.
Okay, so we are setting up scanner further. Tune source, I don't know what it does.
Yeah.
Okay, we know only that returns an error, right? So, and then the runner. Okay, we are loading runner.
Yeah.
And if we are successful, okay, it looks like we have Waitgroups. Okay, so that could be our first suspicion that we are setting up some number of Go routines.
Yep.
And then setting up the wait group to be able to join later on then.
Yeah, well, there's a rate limiter as well. It's a shame Thibaut's not here because he's just written a rate limiting library. He'd be very interested. He'd probably think, I wish I knew that existed. Then I wouldn't have to write it.
Okay, so we have rate limiter, scan workers. So presumably these workers are the Go routines. Okay. We are setting up slice of IP addresses in the network. Don't remember exactly from the net package because is it IP net is the network address or yes number
it's a network address, not a host address. I think probably because that sounds like if you specify multiple targets, you could have enumerated all the IP addresses, or you could give a network address in CIDR format, let's say, like a /24. Or,
yes, and maybe then we know automatically that what IP addresses are in given range, and then we can scan them.
Yeah, so if you're not a networking person or, you haven't got the massive TCP/IP complete manual on your desk, don't worry about it. It's just, clearly this is just a way of working out what addresses we're supposed to hit. It's all paperwork, isn't it?
Yes. Function targets.
And this is, I don't know how people feel about this in terms of, first impressions looking at code. I would say this is sort of like relatively average to slightly off-putting. Sometimes you look at code and it's just super simple, isn't it? Like nobody would have any problem working out what it's about. Other times it's totally impenetrable and we have no idea. And most times it's probably something like this, isn't it? Like we can recognize there are some loops and things here, and we're returning error and checking the error. We're all completely comfortable with this. I was saying to someone earlier that the language, the name of the language should actually be if o not equals nil. Because we use that a lot more often than the Go keyword, don't we?
Yes.
But I think it's in huge part to do with confidence, our ability to tackle code like this. Is if you have written a lot of code, let's say, you sort of probably feel that you can look at somebody else's code and it's not like they're going to be doing anything so ingenious that you can't figure it out. Whereas if you're a brand new programmer or new to Go, you very much might feel like that, mightn't you?
But as well, it reminds me what actually Uncle Bob is in many of his talks. He mentions about the different level of abstraction used in, let's say, function, inside a function or inside a class.
Right.
That mixing the very low level, like loops or reference to particular, let's say, variables with the already abstracted certain actions in terms of the functions, mixing this makes a little bit of reading mess.
Yeah.
So it distracts.
Yeah, I agree, and I think, I feel the same way, not necessarily because I'm a devotee of Uncle Bob, although I find, he has a lot of sensible things to say, as well as some extremely crazy ones. But it just makes sort of common sense, doesn't it? That it's easier to read a function if it's all more or less at the same kind of level of abstraction.
Yeah.
If we're doing very high level stuff and then all of a sudden we're getting way down into the weeds, like, we're 6 levels of indentation into something, that's just hard because your brain's having to jump up and down levels all the time. So it's a nice tip. But if you're looking at your own code and thinking, I wish it didn't jump around levels like this, perhaps that's a sign that you should be taking some complicated chunk like this and just push it into a function.
Yeah. But this is actually good lesson for us when we are, let's say, not familiar with the code, and what's more important, not familiar with the field of, let's say, networking. Would be easier for a person that just started learning this field to have a little bit abstracted with proper name of the functions, more descriptive, for example. Exactly, and this is good lesson for us how we write our code, that we should think that someone else will be reading this at some point, not only we.
Yeah, that's absolutely right. Yeah, we can add, like when, they've put comments here, but in a way, we could have eliminated the need for these comments by just making a function called scan workers or something, or shrink IPs, I actually prefer naming functions like that to just sticking comments in. So fine. So there's some networking paperwork going on here, isn't there? And then it looks like we're getting closer to the bit that does the stuff. So
okay, so it looks like we are getting here statistics from our scan. So counting the IPs, then ports.
Yeah, we're setting up the work that there is to do, aren't we? It looks like.
Yeah. Range. Okay. We are setting up the progress bar. So some parts of the user interface here. I would name this like this. And there you go. Okay. And after the progress bar, checking if the OS and operating system is supported.
Yeah, it's quite neat that we have a progress bar, isn't it? It's I've assigned this as a project from time to time, just because I like projects where you can specify the entire thing with as few words as possible, and yet there's a ton of work to do. And I think progress bar is one of those things, isn't it? Like, it's only 2 words, but actually if you try and write it, there's a lot to do there. Not necessarily in like, can I print stuff to the terminal. But how does the API work? You know, what is a progress bar? Is it some object that has methods, and what are they? How do we do it? It's inherently asynchronous, because the idea is it's updating the user on progress while we're doing something else. So how does that work? You know, how does the concurrency work? How does the progress bar know what the progress is? How do we tell it what progress to report? Is it based on time? You know, and if so, how do we know how long it's going to take in advance? We don't. Is it based on how far through the work we've got? But then that's potentially misleading, because not all the work items take the same amount of time, right? You ever installed some program, especially on Windows, and the installer shows you a progress bar and it gets to 99% really quickly, and then it's just there for ages.
Yeah.
Stuck on 99, and you're like, the progress bar lied to me. It told me it was nearly done, but it wasn't. So that stuff is hard. And we probably better not look too closely at it today, but we can come back to that. So we've got a label here. This is cool. So yeah, wow. I have to say, I think this, I'm not, you know, some people who've been through the Uncle Bob School of Software Engineering are like, no function should be more than about 5 lines. You know, I think that's too extreme, especially in Go, since lines do less than lines of other programming languages. So we generally need more lines just because it's Go. You know, 3/4 of them are if not equals nil. So, but I think this is a bit long and detailed, and could have been broken up into more understandable code. But it's okay, because we're the smart party, so we can figure this out. Let's have a go.
Okay, so we're definitely checking the retry numbers. So
yeah, let's start here. So what's a new BlackRock? Don't know. There's this IP Ranger library, also part of the same project. I would guess from the name that's maybe something lets us iterate over a whole bunch of IPs. That sounds reasonable, doesn't it? Why 43? Don't know.
Yeah.
So if it had been 42, I might have guessed maybe that's just the answer to the ultimate question, but 43 means something magical, I don't know what.
Probably it's very clear for the members of the team that wrote this
Yeah.
program.
Yeah, so we've worked out how many targets and how many ports, and that gives us the total number of, I guess, connection attempts, something like that we need to make. And we're going to do something with that IP Ranger. Let's try and figure out what. Here's the loop. Just walk us through it step by step.
Okay, so we have a loop. We are
Starts
looping
at 0, looks like.
Yeah, until the range. Okay, so this is basically, okay, shuffling index.
Any clues? No? This is where some documentation comments would have been useful, isn't it?
Yeah.
I bet if the people who wrote this library are watching right now, I'm sure they're thinking, but I was totally going to write a documentation comment. I was going to do that last, and then it got to 5 o'clock, and then I had to go, and I was going to come back and do that, but then I forgot. So don't worry, we forgive you.
Looks to me that we are picking up some IP address from this range, because we are okay, that's my understanding, or I can only think, okay, we are shuffling, picking up the index, which is...
Yeah, are we doing something in a random order? Is it like, are we, to avoid, you know, one easy way to detect port scanners is to look for people opening connections to sequentially numbered ports. So maybe if you randomize them all, it makes this harder to detect.
Oh yes, that would make sense, right? So we randomly picking up the either ports or IP addresses here. not to be detected that we are, let's say, IP after IP from certain range, and then every IP on, for example, ports that are going as well, they are incrementing by 1 or whatever number.
Yeah, and I guess we're mixing up the IPs and the ports, isn't it? So we're randomizing all of them. So we're not even necessarily making consecutive connections to the same machine. We're just, we have a billion connections to make to every combination of host and port, and we're just going to make them in random order, I'm guessing. Let's work with that hypothesis. So we're picking one from this randomized thing, picking an IP, picking a port. We feel like there must be some kind of connection attempt coming up, don't we?
Yeah, and if we are lucky, we are continuing with limiter take. Otherwise, we will again we'll continue. So we will pick another IP address.
Oh, take should block to make sure that the RPS is met. That's not necessarily a model of great technical writing, but I think I understand what they're saying is that if we are rate limiting ourselves, which it would make sense to do, then there must be times when it's not okay for us to do anything yet. Because we would otherwise exceed the rate. Like if we say to ourselves, let's only make one outgoing connection attempt per second, then if we've done one this second, then we just have to wait until the next time period. And maybe that's what this does, is it just blocks us until we're ready to do the next thing.
Okay, so then we have, if all these requirements are met, so we are assuming that we are root on supported system and particular scanned options here in the sync scan, then we are going enumerate through the row socket IP port.
Yeah.
And if not, handle host port, and we have go routine here. Okay, here we are adding wait group and starting separate go routine.
Yeah, we don't totally know what this is about, do we? But this is maybe, we're seeing the SynScan option again, so this is maybe if we're in SynScan mode and we have all the required permissions and OS support, then start blasting packets at random sockets in a raw manner. Otherwise, it's not a SynScan, so we don't need any of this special stuff. We can just do, this is a wait group, isn't it? So yeah, just register a new go routine and do handle host port. Well, handle is one of those words that doesn't actually tell you anything, isn't it? Like in an HTTP server, okay, I know what a handler is, but what's this handling? In what sense handle?
Yeah, I mean, this might be personal preference, but the word handle to me is always like, hey, I'm in the middle of something and I got something back and I need to handle it.
Right.
And like it's a reactive method rather than like, hey, go do something.
Yeah, it's like an incoming call from my wife. I need to handle this. So we don't know exactly what that is, but that's clearly, I mean, that must have been the thing that did the stuff, isn't it? Because now we update the progress bar. Increment packets by 1, so I guess we're sending 1 packet here. Should we just take a look to see what's the rest of this, or we would like to dive into handle host port, wouldn't we? This looks like sort of winding down, doesn't it? So this must be the big loop here. Why did we have a retry label? We'd expect to see a continue retry somewhere, wouldn't we? Or a break retry.
There's a go-to retry.
Oh, God. That's alarming.
Current retry, okay.
I saw somebody on Hacker News the other day passionately arguing that goto is not only okay but actually essential. I forget what the substance of their argument was. I was just impressed by their passion. I just thought, I only wish you could be passionate about something more interesting. But yeah, okay. Let's try and understand this. Why would we retry in the first place? Let's ask. Any thoughts?
Well, I guess that just means you're not done scanning all the IPs in the range, maybe.
Doesn't the loop already handle this though? I mean, aren't we looping over all of the work to do? So, if so, having completed that entire loop, we increment current retry, and we say if we haven't yet reached options retries, which is the number of retries for the port, go to retry. So, yeah, I'm guessing it's like maybe, networks are unreliable, aren't they? So maybe you could send a packet and it just didn't get through for whatever reason, so maybe you want to try multiple times to make sure, that port really isn't listening. It's not just that we lost the packet somewhere along the way. I think it could be that, but
that's my thought as well. Yeah.
Yeah, but I wish they wouldn't use a label in a goto. That's
what I don't understand is how they know it's that they need to retry. All they're doing is incrementing a value called current retry, and just saying, hey, if I haven't retried enough, go retry.
Yes, I see what you mean. They're just retrying regardless, aren't they?
Yeah, which makes me think that maybe this is somehow part of the loop.
Are we inside the loop and I just forgot? No.
No, we're not. I just, again, I'm just trying to figure out why are they implementing it this way? Is it something to do with saying, hey, I'm going to check these, retries isn't something failed. It's like I'm going to actually do this multiple times to check the validity of my results.
Yeah, perhaps? I think you're right. I think that's what they're doing. It's not when we see retry, we think, maybe it didn't work and we'll have another go. But I think it just means do it X times. May I just insert a brief explanatory note about labels for those who don't know, which is probably quite a lot of people because it's super rare to use labels. I don't think I've ever used a label in Go, and nor do I plan to. So what are they and why do you need them? This is on my mind because I'm just writing this section in the book that I'm working on. For the Love of Go Control, coming soon. Which, as the name suggests, is about control structures, and of course loops are a big part of that. And if you have a loop, it loops and it does the same block of code several times, and that's great. And we can do things like continue, where we can say, hey, for whatever reason, we're not interested in carrying on with this loop iteration. We just want to get straight on to the next one. We're skipping, in effect. Continue should really be called skip, because the one thing it doesn't do is continue. Continuing would be executing this code, wouldn't it? Whereas what continue does is says skip straight back to here and start again. But that boat's sailed. We can also break, as if to say we're not interested in any more iterations. We're just bailing out. And so we could break. But then the problem arises, what if you have nested for loops? So what if what if you're inside an outer for loop and then you're inside an inner for loop and you want to break out of both of them? You can't just say break, because you'll just break out of the inner loop that you're in. Same thing with continue. If you want to break out of both loops, what you can do is put this label, or literally any word followed by a colon at the start of a line on its own, and you can then use that as an argument to continue or break. So you could say break retry, which would break out of the loop identified by the label retry. Does that make sense?
Yes. I'm thinking some more about that retry. Maybe they want to do multiple runs to get statistics about it. First first time I scanned this IP, it was, you know, this time, this, you know, took this long, I got this result. Maybe it does like some kind of average or something.
Yeah, it's not an unreasonable idea, is it? So the horrifying thing about this label business is if you have a label, you can not just continue or break to it, which is a relatively straightforward thing to do, but you can also just go to it. Like, just jump right there. You know, go to is a really old concept in programming. It goes back as far as the earliest programming languages, as far as I know. Just because in machine code, that's generally the only control structure you have, right? You know, machine code doesn't tend to have loops and things. It just says jump to address X. And that's, so you can then build things on top of that by saying, suppose we have some loop counter X, you know, set it to 10, do the thing, decrement it one time. Did we reach 0 yet? If not, jump to the start of the loop. However, once we have things like for loops, we really don't need goto. And some people have pointed out that goto is used in the standard library in various places, and I think that's having looked at the code in question. It looks to me like that's purely because to do it any other way, not involving goto, would be much worse. You know, they would have to jump through so many hoops, reorganize the code in such a way just to avoid goto that it's not worth it. Because the standard library is very special. You're not supposed to look in there and copy what they do. You can look in there. That's fun, as we know from previous code clubs, but don't necessarily take it as a model or an argument for why you should do something. So, sorry, that's the end of my goto rant. But I mean, the fact that we're puzzling over it is a big red flag, isn't it? It's just not obvious. I'm a big disciple of OOP, as you know, obviousness-oriented programming. And this definitely isn't it. So sorry, Nabu authors. Could do better. So fine, so shall we go and see what the stuff is about? Thom, would you mind taking over the speaking again for a moment?
Sure thing. The runner has, as we know from the previous function, a wait group associated with it. So the first thing we're going to do is say, hey, when I'm done with this handle host port method, call done on that wait group.
Yeah, should we footnote wait groups?
Well, you might have to help with that. Wait groups are a bit outside my comfort zone, other than, you know, the general idea that they're to do with concurrency.
Yeah, all we really need to know for the purposes of this is that we have a bunch of Go routines going on, doing stuff concurrently, and we need some way to keep track of them and know when they've all finished. Otherwise, we might exit before some of them are finished, for example. So that's what a wait group is. It's part of the standard library that just lets you say, hey, I started a Go routine, please remember to wait for it. You know, it's like if you take your kids to the mall and they all run off to different shops and you're there in the car and you're like, when, I know I had 3 kids at the start, so when 3 kids have returned to the car, it's okay for me to drive home. Until that point, I'm still waiting.
That makes sense.
And I'm sure some of us have accidentally driven home without the full complement of kids. So a wait group would be very useful in that situation. So basically it's a counter, isn't it? It's just you can add one to it to say, hey, I started another Go routine, and the Go routine itself will generally call done to say, hey, I'm done. You know, 3,000 other Go routines are not yet done, but they will tell you when they're done.
Yep, that makes sense.
So great.
Okay, so we're gonna do that at the end when we leave this function. That's going to happen before we leave. Then we're going to essentially check to see if we have any exclusions, or essentially have we provided any exclusions somewhere along the line. So if not, can I scan if CDN this host and this port? Then basically say, well, I have to skip this one and leave, be done.
Yeah, the name is a little confusing. As you sort of implied, it should really be called something like "If I can't scan, can I not scan?"
Yeah.
So I think I'm guessing this is like, there are certain well-known IP ranges which belong to CDNs like Cloudflare and Akamai and people like that. And we're not interested in scanning those, or we would like the option to avoid scanning them in any case, because that's probably a waste of time. They're not the real server; they're just some proxy server in front of it. So,
for sure. And then I'm going to check to see, is there a port, or at least that's my assumption. If r.scanner.scan results.ip has port, given the host and the port. So basically, have I already scanned this thing?
Oh, right. Okay.
Is what it looks like to me. Have I already assigned this port to the scan results? Is what it looks like to me, because otherwise, why would I just stop?
Yeah, again, a slightly confusing name. IP has port. Every IP has every port. Let's just take a look. Yeah, I think you're exactly right. Yeah, I think it records the IP and port combination that it's already scanned. And we're just checking if we did it. So, yeah, great. That makes sense.
And then we get to the business of actually connecting to the port and scanning the results. So we're gonna call a connect port, which is in a package called scan. And we're gonna pass it our host, our port, and interestingly enough, a timeout value rather than a context with a cancel or something.
Yeah.
Not that you have to use context everywhere, obviously.
Yeah, see previous code clubs for more information about context cancel on all of those. But yeah, we're just using a timeout, presumably because that's, maybe we can pass it direct to netdial or something. I'm not sure. But all of this machinery in Go long precedes the context library, so that might be why.
Yeah. Fair enough. And then, so open connect port must return a Boolean.
Yep.
Basically saying, yep, I connected, presumably.
Yep.
And then also checking to see that there was no error returned.
Right.
So presumably then you could get a connection, but there was an error also.
Right. But if not, add it to this scan results thing.
That's right.
To say, hey, I scanned it and I found it was open. So clearly this is the bit that does the stuff. So let's dive a level deeper. You can almost feel the hull creaking under the pressure now, can't you? We're way down.
You were exactly right about netdial.
Yeah, that's cool.
So the net package, of course, is in the standard library.
Yeah, if I'd been way off base, I just would have edited that bit out.
And dial with timeout takes in a time duration.
Right.
So connect host, connect port. We provide it. We tell it we're going to connect to TCP because that's what this whole thing does. And we're going to tell it what IP and port to connect to and how long to wait. And then we're just going to return, did I get connected?
Yeah. So we're down to the standard library TCP stack here, aren't we? So netdial, which is the sort of non-timeout version of this, just tries to make a TCP connection to a known host and port, and if it can, it gives you back this con object. And a net.con is basically the thing that then allows you to talk to that machine. So having set up the con, it's like a telephone circuit, which is presumably why dial. You know, you now have a thing which, interestingly, is an IO writer. So you can write to it, and you will send that stuff over the connection. And similarly, you can read from it. They might want to talk to you. As it happens, we're not interested in any of that, because we just wanted to know, could we make the connection? So having made it, it's like we dial someone and then immediately hang up when they answer.
Yep, that's exactly what's happening.
We close it and we return true to say we could do it. So, and there are some other things here, but we probably don't need to worry about these too much, because we kind of saw the main thing, didn't we? And
if you could go back to connect, I'm just curious. So they have in the previous function, they have if open, which is the Boolean here,
right,
and error does not equal nil.
Yeah.
Or sorry, and error equals nil.
Yes.
I don't think that's actually a valid case based on the connect port function. It only ever returns false, and the error. Oh, never.
Yeah.
I'm wrong about that.
Yeah, this should be nil though. I mean, it will be nil.
Yeah. It has to be nil because they're catching the error and returning false with the error. So they never would get to, and they just,
Yeah, that's right. We set it here. We return if it's not nil. So if we get here, we know it is nil, and then we return it. So it's a nice refactoring to explicitly put nil here, because it signals to anybody reading it, hey, it's actually nil. Otherwise, as you rightly point out, it looks like you're returning some error.
Yeah.
And
then in the other function, they could refactor that to be basically do the kind of idiomatic thing, which is just, okay, did I get an error back?
Yeah.
Nope. Okay, now I can just say add port.
Yeah, we don't really need error here, do we? Because we're not going to use it if it's not nil. If it's not nil, we just ignore it.
I mean, in fact, they don't even need to return a Boolean at all. All they have to do is return an error, and if the error is nil or not is nil, then go ahead.
Right, and when you don't care what the error is, only that there is one, you could just return bool, couldn't you? So you could call this something like can connect port.
Yeah.
If you can't, I don't care why. Maybe it's because you're not listening, maybe there's an error, something else, yada yada, but I basically only care about the happy path case.
Hi, I had a question.
Sure.
Welcome,
Evanson.
Thank you. I had a question on that return value, bool and error. I've noticed quite a lot of networking projects that are written in Go. Most of the authors return bool and error while they shouldn't return both. They should just return the error, because if there's no error, then I know I already succeeded in doing what I wanted to do.
Yeah.
So I wanted to hear your views about that paradigm of returning bool. To me, it doesn't make sense.
Yeah, I mean, I think it sort of depends what you're interested in doing with the information, isn't it? I mean, it's a good question, because, usually when you connect to things, it's because you then want to do something with that connection. This is a weird and unusual case where we're not interested in doing anything. We only wanted to know, could we make the connection? So as Thom was rightly saying, we could have just returned bool here because that's the only thing we're interested in. However, when that's not the case, instead of returning bool, we would probably return the con object or something, wouldn't we? So we could do something with it, or some wrapper that uses it. But if there is an error, usually we'd like to do something with that too, wouldn't we? It'll be helpful to even just to print it out to the user to say, here, sorry I couldn't make that connection and here's what went wrong, you know, bad IP address or something. Or...
Yeah, I think in this case I would return an error only, and then you've got multiple use cases. You can say both, okay, well, if I didn't get an error, then I'm safe to add my results. But if I did get an error, I can maybe, now I have the utility to say, do I want to know what went wrong in this case?
Yeah. Yeah, that makes sense. So it's like, yeah, if this was only ever used for this one very specific application, they could have got away with returning less stuff. But perhaps wisely, they chose to make it a bit more flexible. You know, better to have the information and just ignore it rather than not be able to get it. Yeah, that makes total sense. Well, we're kind of at our time, so we better wrap up for today. But it's been a really interesting one. I've quite enjoyed this. And there's probably a lot more meat we could get out of this library, because I'm pretty sure they do some cool and interesting stuff. So you may like to take a look at this project offline, and I'll share the link in the description. But thanks very much to everybody for being with me. It's been a real pleasure. I'll see you all next time. Bye for now.
Thank you. See you.
Bye. Bye.